Hey everybody, Miss Z here, and today's video we are going to talk about solubility rules and particle diagrams. So we have some vocabulary terms that we need to know in order to talk about solubility and draw particle diagrams well. So some of our vocabulary, the word soluble. Soluble means a substance that can dissolve. And we could also say that it dissociates into ions. So ionic compounds, when they dissolve, they are going to dissolve into their respective ions of their metal ions and their non-metal anions. Covalent compounds are going to change from one big chunk to individual molecules. Okay, so like sugar would go from a chunk of sugar and then individual molecules would come off, whereas salt would go from a chunk of salt and then sodium ions would come off and chloride ions would come off. The term insoluble is in reference to a substance that does not dissolve, whether that's into ions, they should say, or molecules. Okay. We like to label these in terms of states of matter. Something is soluble, we say that it's aqueous, which is a state of matter of a substance that is dissolved. In aqueous, we abbreviate as AQ. And then a solid is how we would refer to something that is insoluble or does not dissolve, and we use a little s for that. Liquids, we use a little l, and then gases, we use a lowercase g. So we'll start to label all of our compounds and elements in chemical reactions. Now, how do we tell if something is soluble or insoluble? That has to do with the elements that are in our molecular ion. If it begins with a group 1 metal, so remember, group 1 metals is any element that's in group 1 of our periodic table. So hydrogen, so that's all acids. Then lithium, sodium, potassium, rubidium, cesium, and francium. These are all soluble in water. So any compound that begins with one of those metals is soluble, and we say that it's aqueous, no matter what it's combined with. Then the rest of these look at the anions or the endings. So just like you are related to other people with the same last name as you, compounds with the same last name are also related and have similar properties. So any compound that ends with nitrate is soluble, and we say that it's aqueous. Anyone that ends in acetate, sulfate, or chloride. All of these are soluble all the time. And although this isn't completely true, for our purposes, we're going to say that everything else is insoluble. Now, we'll come to a few different things where I'll say, hey guys, this is an exception to the rule, and it really is soluble or insoluble, even though our rules say it's not. But for our purposes and moving forward, we're going to just focus on these 4 anions that are soluble, group 1 metals, and we're going to say everything else is insoluble. So to use this chart, I'm going to look at my formula. So I have sodium chloride. First, I check to see, does it begin with a group 1 metal? Sodium is, in fact, a group 1 metal. It's in group 1. Therefore, this is soluble or aqueous. Okay. Magnesium nitrate. First, I check magnesium. Magnesium is in group 2, therefore not a group 1 metal. So then I check the anion or its last name. It ends in nitrate, and my chart says nitrates are soluble. So this is also aqueous. Iron 2 bromide. Iron, I check to see, is it in group 1? Nope, not in group 1. Well, then I look at its last name, bromide. Not nitrate, not acetate, not sulfate, not chloride. So it must be in my everything else category. So it's insoluble, or S for solid. Okay. The reason that we need to know our solubility rules is so that way we can write a chemical reaction. We can react 2 reactants together. And with that information, knowing what our products are, be able to look at our beaker and say, well, this must be my sodium sulfate. This must be my copper 2 bromide. Based on what I know is soluble or aqueous in my solution, what's a solid, what's a gas, or what's a liquid. So let's do some practice. I want to write a balanced chemical reaction for my double replacement reaction above. Sodium bromide, remember sodium plus 1, bromide minus 1. Copper 2 sulfate, so copper is plus 2. Sulfate on our list of ions, SO4 minus 2. Copper 2 bromide, Roman numeral tells me my charge, so copper plus 2. Bromide minus 1. Sodium sulfate, sodium plus 1. Sulfate, SO4 minus 2. Swap and drop, NaBr plus 2 and 2, so they cancel out, CuSO4 makes Br2 and Na2SO4. Okay, I'm going to assign states of matter. This is a compound. Compounds, we need to look at our solubility rules. If I were to have an elements I would look for on my periodic table. And on the bottom of our fancy periodic tables we have, it tells us our states of matter. Black are solids, blues are liquids, greens are gas, grays are synthetic. We're going to assume that means solid for our purposes. Okay. Sodium bromide is a compound. It starts with group 1 metal. Sodium is in group 1 right here. So that means this is aqueous. Copper 2 sulfate, not a group 1 metal. However, sulfate is soluble. So this is also aqueous. Copper 2 bromide, copper, not group 1. So I look at my ending, not any one of these. So it must be in everything else. So it's insoluble. So that's a solid. And sodium sulfate, sodium group 1, aqueous. Whoops, I forgot to balance this. We should do that. 1 sodium, 2 sodiums. So I put it 2 here. Gives me 2 bromines, 1 copper, 1 copper, 1 sulfate, 1 sulfate. And we can put parentheses if we want. All right, we need to draw a diagram. So we are going to have our beaker to start with, that we react the two together. And then we're going to have our beaker at the end. How did I do it for your homework? Guess we got 2 beakers to begin with. All right, we're going to cut our beaker in half. Our beaker has a partition. So my first one, aqueous. That means it's dissolved in water. I'm going to draw my little liquid. Dissolved in water means it's dissolved into its ions of sodium and bromine. So sodium ions, bromide ions. That's why we write them above as ions. It helps us out later. And we have 2 sodium ions. So we need to have 2 of them. 2 bromide ions. So 2 of those. Then my other reactant, so my other little half of my beaker, my other beaker, I have copper ions, again aqueous. Maybe we have a little less of this. So copper ions and sulfate ions, ionic compound, we said splits into our ions. And I have 1 copper and 1 sulfate. When I mix these two together, I notice that I have copper 2 bromide is a solid. So we're going to have a pile of this. I don't know what color it is. Maybe it's bluish green. Copper is usually a bluish green color. So I'm going to have my copper 2 bromide, and I just looks like I have 1 molecule of that. So I'm going to write CuBr2 as my solid down at the bottom, and I just write it once because I just have 1 of it. And that means floating around in my solution, I have this aqueous compound, which really means it's split apart into its ions. I have 2 sodium ions and 1 sulfate ion. Okay, so I have shown this, their states of matter, and it is balanced correctly. 2 sodium ions here, 1 here, 1 here. 2 bromines are represented here. 2 bromines are in my compound here. 1 copper, 1 copper, 1 sulfate, 1 sulfate. Let's do one more that has a couple different states of matter. So in this reaction, we have aluminum. Aluminum is a metal, so it's just Al. Hydrochloric acid, hydroic acid. That comes from chloride. Chloride, Cl-1. It's an acid, so it starts with hydrogen. Hydrogen's +1, so it makes HCl. I'm going to make hydrogen gas. Tells me state of matter here. So hydrogen is a diatomic. So H2, it tells me it's a gas. I'm going to put my little gas down here in parentheses. And aluminum chloride. Aluminum chloride is ionic, so +3. Chloride is an ion, -1. Swap and drop, AlCl3. I need to go ahead and balance. I have one aluminum, one hydrogen, 2 hydrogen. So I'm going to start by putting a 2 in front. Gives me 2 chlorides, but I have 3 chlorides. Well, what if I change these 2 and 3 are really divisible by 6? So let's change this to a 6 on the front. So I get 6 hydrogens, which that would be a 3, 6 chlorides, and that's a 2. Make that 6. So then 2 aluminums, 2 aluminums. Lots going on in this one. So states of matter. Aluminum, it's a metal. Can double check periodic table. My symbol is black. So that confirms that's metal, so that's a solid. Acids are always aqueous. Acids are always aqueous. Hydrogen told us it was a gas. Aluminum chloride, ionic compound. So I need to go up and check my solubility rules. Aluminum is not in group 1. So I check my ending, chloride. Chlorides, soluble, aqueous. So this is aqueous. So I'm going to go ahead and draw my beakers. I have each of my reactants in their own beaker. Unless sometimes you might have all your reactants in one beaker, and that's fine too. Just depends on what you're starting with. So I've drawn my beakers. So aluminum is a solid, and I have 2 aluminums. So I'm going to draw my pile of aluminum solid, and I'm going to put 2 aluminums here because I have 2 atoms of aluminum that I need to have. Hydrochloric acid is aqueous, so it's dissolved in a liquid. In our case, it'll be water. I need to have 6 hydrogen ions and 6 chloride ions. 1, 2, 3, 4. Didn't make enough room. 5, 6, and 6 chlorides. 1, 2, 3, 4, 5, 6. Oof, I got busy. Then my products, I have hydrogen gas. So I'm going to show that as little gas bubbles coming out of my beaker. And I have 3 molecules of hydrogen. Okay, so it's a molecule, so it's going to stick together, right? It didn't dissolve. So I'm going to write hydrogen as my diatomic 3 times on here to show the 3 of those that come out. And then I have my aluminum chloride that's aqueous in my solution. I have 2 aluminum ions and 6 chloride ions. Like so. The next step would be if you knew the colors of them, which you will for your lab that you'll do or that you'll observe. And with the colors, then you would also color things incorrectly. So you'd make aluminum a gray solid. Hydrochloric acid is clear and colorless. Hydrogen gas is also clear and colorless. And aluminum chloride might have a color to it. If it did, you would color that appropriately.